Hey folks, in this video we're going to talk about some concepts and some conceptually difficult stuff, and also hopefully do an example or two of rolling. Okay, so the first concept I actually want to speak to is from the previous video. So in the previous video we talked about a disc or a cylinder rolling down an incline, and we calculated its final velocity. All right, and then we calculated its acceleration, and we did it a couple different ways. I'm going to focus on the energy one right now, though. So if the final velocity of our cylinder was root 4/3 g d sine theta, okay, what would it be if we changed the shape? Okay, so if we changed I, what would happen? Okay, so for example, while a cylinder has a moment of inertia of 1/2 mr squared, what about a hoop? Okay, well, a hoop has a moment of inertia of just mr squared because all the mass is at the edge of at the radius r from the center. So if I made I bigger, okay, what would happen to the final velocity? Well, the left-hand side, which assume the mass of the cylinder and the disc, or the mass of the hoop and the disc are the same, so the left side wouldn't change. So if I went up here, then V and therefore omega, because V equals R omega, they would both have to go down. So the bigger the moment of inertia of an object, the less it accelerates and the slower it will go at the bottom of the hill. Because think about what moment of inertia means. It means resistance to changes in motion. Well, the bigger the moment of inertia is, the more resistant that object is to accelerating. Okay, so that was the first concept I wanted to mention to you. The next concept I want to talk about is friction and its role, no pun intended, in moving things around. Okay, so let's say we have our incline and our cylinder rolling down the incline. Okay, so first of all, which way does friction act? Well, in the previous example, we said it acts this way. Friction is making the cylinder roll. Otherwise, it would just slide down the hill without actually rolling. So friction does the rolling for us. It makes the thing roll. Now, the next question I have for you is, what kind of friction is this? Okay. Well, people often say, well, there's movement, so it's kinetic friction. No, no, no. This part of the cylinder is not moving relative to the incline. So this is static friction. Now, you could have kinetic friction acting if you made the incline steep enough such that the cylinder was skidding as it rolled, then you would have kinetic friction. But if you're just rolling without slipping, then it's actually static friction that's making this thing roll. Okay, so it's against the motion and it's static friction. Now the last question is, does that force of friction do any work? Well, the answer is yes and no. Okay, now first of all, can static friction ever do work? Yeah. Okay, so for example, let's say I've got a book and then I've got a stapler on top of the book. If I pull the book, what force moves the stapler? Well, friction, and friction's speeding up the stapler. So static friction is doing work there. So that's just one example of static work doing friction or doing work. What about in this case though? Okay, well, that friction really isn't acting through any distance, whereas like over here, this one is. So the static friction is not changing the overall energy of the disk. Okay, but it is doing something. Okay, it is converting. You can think of it this way anyway. It is converting translational kinetic energy into rotational kinetic energy. Because if there was no friction at all, okay, you would have mgh would turn into 1/2 mv squared. Well, because we have that friction, we get rolling. So we have mgh turning into 1/2 mv squared plus 1/2 I omega squared. Now I'm writing fast there, but you get the idea. This term has to be smaller than this term because the left side of the equation is the same in both cases. Okay, so this had to go down to make this be there at all. So you can think of static friction as converting one form of kinetic energy to another. So that's one way to look at it. Okay. Now, another conceptual idea, this comes up in test questions all the time, is, let's say you have a disc and it's rolling without slipping, and then it reaches an incline. Okay, so there's your incline. Okay, so it's going to roll up the incline and come to a stop at some distance d up the incline. Okay, and then it's going to roll back down. All right, under which circumstance would the disc go higher? If the incline has static friction, or if the incline doesn't have static friction. Under which circumstance would the disc go higher? Okay. Well, the snap judgment would be, oh, if you got no friction, it's going to go higher. Well, it turns out that in this case, that's incorrect. Okay. While this disc is rolling up the hill, which way does friction point? Let's start with that one. All right. Well, this part of the disc right there, it's trying to go left. Friction opposes that relative motion, and static friction in this case, believe it or not, actually points up the incline. Again, friction is resisting the relative motion between the two objects. Well, if this thing is spinning like this, that little part of the disc is trying to go down the incline. So friction opposes that relative motion and pulls up. So it turns out that friction is actually helping the cylinder or the disc go up the incline. Okay. Now, the other way I look at this is with energy. Okay. We'll do friction and then we'll do no friction. Okay. In both cases, when the disc is down here and it's rolling, okay, it's got 1/2 I omega squared. Let me rewrite that. Okay. 1/2 I omega squared plus 1/2 mv squared. And in both cases, whether there's friction or not on the incline, assuming there's friction on the ground, you're going to have these two types of energies, and they're going to be the same in both cases. Okay. Now, what about after? Well, if there's friction, when this thing gets to the top, it's totally stationary. There's nothing about it moving. So this all turns into mgh. What if there was no friction? Okay. Well, if there was no friction, when this disc got to the top of the incline, wherever that might be, it would still be spinning because there's nothing to stop it spinning. So it would stop moving forward, but it would still be spinning. So you would still have your 1/2 I omega squared sitting there. And then you would have an mgh. Okay. Well, this term has to be less than this term because you've got this term sitting there, assuming the left sides of the equation are both the same. Okay. So this height would be smaller than the previous height because you haven't, this rotational energy hasn't been converted to gravitational potential energy. Okay. For this, so we're not going to get to our example, but I did want to spend some time talking about concepts and really thinking hard about, what's changing, what's not, and what's the role of static friction in rolling, no pun intended. So those things are actually quite important, and if you really understand them, it helps you with the math and the solving of problems. So in the next video, I'll do several examples with you. So I hope this video was helpful, and thank you very much.